Hi, James from TechDev here. Do you ever experience dropped frames in voice calls, latency or connection issues? Maybe sometimes you have a print job and it fails, or your Wi-Fi connection is so slow that you have to disconnect and reconnect to get working again properly. All of these are symptoms of a bad network. Today, this video is going to be about wireless networks and how to make yours great. We're going to go over the history of Wi-Fi and exactly how it works, and the anatomy of the router. We'll also go over how your computer communicates with the router using its network interface card. Most importantly, I'll show you the most common pitfalls and mistakes that people make with the way that they place their router hardware components. Then we'll cover just how far Wi-Fi goes and what specialized hardware we can use to push those limits to the max. Of course, you might not even know that your network is slow. So we're going to finish this up with a few commands that you can run at home while following along to see just how healthy your wireless network is, and if any of these steps could probably help you out. Many businesses start off with consumer hardware. This can sometimes be a mistake. Consumer hardware is only designed for home use, designed for maybe 2-level structures and very small amounts of use. While it may cover the range of your business, if you have multiple users doing high bandwidth applications, you'll find yourself reaching the limit of the hardware very quickly. Typically, the most common problem that I see is router placement. Computers contain network interface cards, abbreviated NIC or NIC. These NICs are part of the computer and they communicate directly with the router. You can kind of imagine the NIC as a little postal worker where they take incoming packages and they route them to the different hardware components on the computer. And the outgoing packages, the NIC places the labels onto the data packets to determine where exactly they go within the network or the internet. On the most basic level, Wi-Fi works just like radio. It emits light in the non-visible spectrum, and the Wi-Fi receivers are able to measure the light in this non-visual spectrum. And data is carried over it the same way that data is carried over sound wave. There are two main types of Wi-Fi. One is called 2.4 gigahertz, and the other is called 5 gigahertz. These are also called bands. So 2.4 gigahertz band is probably the most common. It's great for longer distances, and it's great for low data usage type devices. Wi-Fi doorbells, Wi-Fi light bulbs, Alexa, things like that where they don't communicate huge amounts of data and they need to do it over longer distances are good for 2.4 gigahertz. 2.4 is also good for outdoor use. The second type is 5 gigahertz. It's more common in things like wireless mouses and keyboards. And yes, those things do use Wi-Fi, but it just doesn't connect to your router, so you don't think about it. 5 gigahertz also has better penetration through buildings, and it also doesn't cover as much distance when you're outdoors. Modern routers are amazing pieces of technology. They have been honed over generations and generations as probably the most developed and over-engineered engineering components in your entire home. They have amazing capabilities for routing data and managing multiple connections. At this point, they're limited to the physical characteristics of the light bands that they use to communicate. They utilize every single bit of the spectrum that they are allowed to communicate on. What this means is that a router will have, for 2.4 gigahertz band, it will have 11 channels that it can broadcast on. And for 5 gigahertz band, it will have 45 channels. And each of those channels is built up. So there are 3 primary channels for 2.4 gigahertz. Channel 1, Channel 6, and Channel 11. Those channels have no overlap. And so for the router to have the best performance, it will choose 3 devices, and those will have the very best performance on the network. The channels are ranked in priority based on how clear they are and how little overlap they have with other channels. So if a device has really high usage and it needs an uninterrupted channel, it will switch it to a channel that has the best throughput, depending on how crowded each channel is. So knowing something like this may seem like useless info, but if you actually remember it, it'll help you know exactly what the limits are of your network. You've got 11 devices that can be far away and 45 devices that can be close. And what that usually means is you can forget about them being close. And by close, I mean 10 meters. That tends to be the limit of 5 gigahertz. So while you don't really have to worry about the 5 gigahertz limit, the 2.4 gigahertz with 11 channels is what you do have to worry about. And while it sounds like a simple task, if you have an office of 8 or 9 people all walking around with laptops and cell phones all connected to that same Wi-Fi, it's actually amazing to think that the router is actively checking those connections, seeing which ones are using more data and less data, and automatically routing them to one of those 11 channels and to one of those different bandwidths depending on their range. And it's keeping track of all of this while making sure that none of the signals interfere with each other and none of the applications being used have interruptions in their data. It's really quite amazing. Now we're going to talk about improving performance of an existing network. So the name of the game when it comes to improving performance is reducing the amount of interference and overlap between your channels and devices. This will allow you to have clear communication between your wireless node and your access point or router. The best way to visualize wireless interference is to imagine the devices talking to each other. The router listens and the workstations talk. So if you have 2 workstations and they're all in a circle around the router very close, you're not really going to have a lot of issues. If you have one workstation or a few workstations that are really, really close and one workstation that's really, really far, you're again not going to have an issue. But if you have a cluster of workstations that are very far away from the router, then all of a sudden those workstations start trying to yell over each other. And we'll go more into what this means a little later. So what this means is that if you have a bunch of workstations in a short distance around your router, they'll all be able to have a normal, room volume conversation and everything gets understood and everything is fine. When things get a little more interesting is when you start dealing with longer distances. If you have a single computer very far away from the router, that workstation has to yell, but the router can still hear it and everything is fine. But if that router is far away from 2 or even 3 or 4 workstations, I mean, imagine trying to talk with 4 people who are at the other end of a basketball court and they're all trying to talk to you at the same time. They're going to be yelling over each other and you're not going to be able to understand what's being said. And this is the same way with wireless broadcasts. Once you have multiple devices together far away from the access point or router, that's when you have the worst interference and even disconnections. Of course, the best solution can be to just move one object, and that object is the router or access point. Of course, in practice, that's the most difficult object to move because it's usually tied to a physical location. But another thing that I recommend is instead of having 2 or 3 workstations far away from the router, is that you can have those same workstations and you can even have them the same distance away. But as long as they're on opposite ends of the router, you'll be fine. And it's the same way dealing with people yelling at you. If you're dealing with people yelling at you, but they're on opposite directions from you, you don't have to deal with them yelling over each other. Each will come clearly, but they'll be from far away. This can even cause problems in a small, congested network. What happens when you have too many devices in a small room is that all the talking creates a noise floor where in order to be heard above all the talking, you have to yell. And you'll see this a lot with people in bars or nightclubs or even just crowded venues where in order to hear the person next to you, you have to yell just because everybody else is talking so loud. And so what this causes is when you have to yell to talk to the person next to you, all of a sudden, all the conversations all have to be yelling. And it gets to the point where, luckily humans have a limit to how loud they can talk. But with these wireless systems, they can all talk so loud that only the closest devices are able to be heard. And they all start blocking each other out by broadcasting so loudly. So finally, we can talk about bandwidth. Bandwidth is the amount of data that can flow through a network at any given time. In a healthy network, this bandwidth is limited by the internet service provider. If you look at what you pay your internet service provider, they'll give you different numbers, and those numbers are actually the amount of bandwidth you're being given. In an unhealthy network, your bandwidth is going to be limited by your wireless network rather than your internet service provider. Your wireless network will only be able to carry so much data over time, and because of that, you'll be missing out on internet that you paid for. Another issue that you'll encounter when dealing with a saturated wireless network is latency. Latency is usually measured in milliseconds, or ms, and it is how long it takes for a packet to be sent and sent back from your router to your workstation. Typically, on a healthy network, you'll end up with single or double-digit millisecond latency. Maybe anything less than 100, maybe 120, 150 is going to be okay for wireless. And you'll notice this whenever you're playing an online game or doing a video chat, that the latency really matters in how responsive everything feels. Even browsing the web will feel a lot more responsive when you have lower latency. And what causes this latency is when you send packets, it takes longer for the router to actually hear it and say, okay, stop sending that packet and send the next one. And then the workstation will send the next one. And then once the router picks it up, and so they're constantly beaming stuff back and forth. So while it may seem not that important to your business to have a healthy wireless network, you'll actually see a ton of negative symptoms that have a cumulative effect on your business. One of the most important things that I've personally seen is when your wireless network is so saturated that things start to fail, you can even have transactions decline. Your point of sale system won't be able to read and validate transactions, and customers will think that their cards are being declined when it's really your network. So I'm going to go over the limits of what a wireless network should normally be. Typically, that limit is going to be 10 users. But if every user has their own office or is far away, then that limit will be 5 users. And you guys probably understand why, because I just went over the limitations of bandwidth. Ideally, you'll have all of those users at an equal distance from your access point or router. I'd also advise that if you have the ability to, anything close enough to run a CAT cable will help improve the performance of your network. By running as much stuff wired as possible, you limit the amount of stress that's on your wireless network. All right, so finally, we're going to go over a few commands that'll show you how to measure the health of your network. So just take your keyboard and you press the Win key, and while holding the Win key, you press the R key. Cool. So CMD, we're going to get this big scary black box. We're going to type in tracer, and we're going to trace a route to 1.1.1.1, which is Cloudflare. It's a very popular internet type backbone. I don't want to call it the core of the internet because I know I'm essentially wrong, but it is one of the networks with the best uptime. What we used to use was Google.com, and now we use this just to determine the general health. And the reason we use this is because everybody has about the same connection quality to this internet service address. So we'll hit enter, and we'll start sending packets, and it will start returning them. The number next to the MS is the number of milliseconds it takes for the packet to return. It'll wait a certain amount of time, usually about half a second or more. And then it'll say, hey, they're not sending a packet. It's considered a dropped packet. The first number is, I believe, the number of hops. And as you can see, we do have a few dropped packets. And that could be anything. There's a million different things it could be. It could be somebody uploading or downloading a large file on our network. Could be a problem with the host, but it does indicate usually that there is an issue with our wireless network here. Part of it could be that I'm doing a lot of broadcasting right now. There could be some signal interference from all the cameras in this room. There's no real way to tell. It doesn't impact what we do here because we haven't tried live broadcasting yet. But when we do, that might turn into an issue, and we might have to run a wired connection when we do that. So the second command I wanted to run with you guys today to show you network health is ping. You can do that same address. You're going to type in -N100. What that -N is it's a modifier to the ping command, telling it to do it 100 times, and we can watch it go. So again, we're just pinging instead of tracing the route. It gives us simpler data. And again, you can see that our millisecond delay is the same between our hops. And so typically on a network that has issues with connection, you'll see inconsistent numbers. Typically, the further away you are from the access point, the larger these numbers are going to be, where they're going to get up to 100 or 200 milliseconds. And after a certain point, they'll be considered dropped packets and they'll have to be reset. So as you can see, we have a fairly consistent, we're staying between 10 and 30 milliseconds. So that's pretty good. You would notice something if you were doing very competitive gaming, or if you were trying to do something that really required a solid connection. And I can't really think of anything other than competitive gaming, because that's what I do sometimes. Yeah, this is the ping command. It should be almost done. I am stalling for time. And at the end of this, it should show us a little report. And so at the end, you can now see it's given us a little report saying it's sent 100 packets, received 100, and it has lost 0. As you can see, this is why it's important to do this command in combination with the traceroute command, because they will give different values. The traceroute command is more discerning. I think what the ping command is doing is it's just counting the ones that are lost on the internet, whereas the traceroute command is counting packets that are lost in the internal network. A packet sent over the internet is more damaging when it's lost, because they do take longer to arrive, whereas a packet in the wireless network is not as serious because it can be reset much more quickly. So typically when it comes to packet loss, like the programs that we just saw, anything around 1% is considered normal, and anything over 5%, you're going to have some serious problems. It's considered unusable. When dealing with latency, anything under 100 is good, anything under 200 is okay, and anything over 300 is considered unusable. So keeping track of these numbers, and there is always room for improvement, and you will usually notice improvement. There are some things that I can do even with my own internal network to tune it, but it does reach a certain point of diminishing returns. But if you are over 100, this is definitely something you want to look at. And if you're dealing with any lost packets basically at all, there is something wrong with your network that can be fixed. I hope that this video has inspired some solutions, or at least informed you as to what's going on in your home office or business network. If this all seems a bit intimidating, you're welcome to contact us at techdev.com and fill out the contact form. And we can, send a technician out that will build a perfectly functional network for you using all these principles and more. And not only will the network function perfectly, but we can also provide room for expansion and long-term support if you have any ongoing issues. We also offer remote consultation for those who prefer to do it themselves, but just need a little bit of help getting started in the right direction. So we can consult you on to what hardware to use, where to place it, and any issues you might have moving forward with that installation and maintaining connectivity. Keep in mind, we are located in Southern California, and we do offer competitive rates for these services. Again, you can fill out our contact form at techdev.com if you'd like to get in touch regarding these services.